Hi, I'm Miss Hall, and this is Lesson 38, Graphing and Transforming Radical Functions. Let's start with graphing. Graphing radical functions. A radical function contains a radical expression with the independent variable in the radicand. When the radical is a square root, the function is called a square root function. When the radical is a cube root, the function is called a cube root function. Parent functions for square root and cube root functions. The parent function for the family of square root functions is f of x equals the square root of x. There's then a picture of the graph and the domain and range. Domain, remember, is the possible x values. So the x values start at 0 and keep growing, so x is greater than or equal to y. And the range is possible y values, and for this parent graph, the y values start at 0 and go up. So the other function you should know is the parent function for the family of cube root functions. And that parent function is f of x equals the cube root of x. This graph looks like a sideways cubic function. And here the domain, right, the possible x values are all real numbers, and the possible y values are all real numbers. Example 1, graphing radical functions. Graph each function, identify the domain and range of each function. So f of x is the square root of 1/4 x. I've already gone ahead and graphed it for you. You could put this in your calculator, make sure you get a graph that looks like this. And to identify the domain, so the domain again is possible x values. The possible x values here are x is greater than or equal to 0. If you wanted to write this in interval notation, it would be 0 to infinity. Range is possible y values. And just like the parent function, the range of f of x is y is greater than or equal to 0. And in interval notation, this is 0, infinity. Okay, so we looked at a square root function, and now we're looking at a cube root function. And here's the graph of g of x, which is -3, the cube root of x. And for this graph, the domain is all real numbers, and x can be any value, and y, or the range, possible y values are all real numbers as well. So after reviewing graphing, we're now going to talk about transformations, and these are the same rules that we saw a few units ago about how horizontal translations, right, affect the x value, x minus h, which is the shift left or right. I would normally say that this is inside grouping symbols because we saw this in quadratic functions a lot and cubic functions. And now that we're seeing it in radical functions, you'll see that the grouping symbols is that radical symbol. So like the square root of x minus 2 is a translation 2 units to the right. Going through these quickly, we have an example of vertical translations, reflections. Remember, for reflection, if you negate the x value, it's a reflection in the y-axis, and if you negate the y value, it's a reflection in the x-axis. We then have horizontal stretches or shrinks. For horizontal stretches or shrinks, you multiply by the reciprocal of the factor, and vertical stretches and shrinks, you multiply by the factor. Example 2, transforming radical functions. Describe the transformation of f represented by g, then graph each function. So we have f of x is the square root of x, that's the parent function, and g of x is the square root of x minus 3 plus 4. So this x minus 3 gives us an h value of 3. And the plus 4 is our k value, k equals 4. So there are two transformations that are happening with an h value of 3. This is a horizontal translation, 3 units to the right, and the k value of 4 says a vertical translation, 4 units up. And you're welcome to graph these two functions, this in y1, this in y2, and see that it really is a shift, 3 units to the right and 4 units up. In B, we now have a cubic function, and we have f of x is the cube root of x, and g of x is the cube root of negative 8x. Okay, so there's two things that have happened here. We've got the negative. We are negating the x value. So therefore, this is a reflection in the y-axis. These are my notes that are going on to myself, like in my head. And this 8 represents a horizontal stretch or shrink. I figured that out last by a factor of the reciprocal of 8, which is 1/8. So I can write this now. So there are two transformations happening here. We have a reflection in the y-axis and a horizontal stretch shrink by a factor of 1/8. Horizontal stretch shrink. So I have to think about, okay, if this is a quadratic and I was multiplying by 8, so let me square this and I'll get 64x squared, and this 64 outside grouping symbols is a vertical stretch. So inside grouping symbols is a horizontal shrink, and that's why this is a horizontal shrink. You can memorize that it's a horizontal shrink if the factor, in this case is 1/8, is between 0 and 1. That doesn't help me because I can never remember if it's the factor that needs to be between 0 and 1 or the coefficient of x that needs to be between 0 and 1. So that's why I have to go through that purple part. Is what I have in my notes when I was prepping for this video. I had to write down this purple part. But if you can memorize it differently, that's fine. Now we'll go on to example 4. So writing a transformed radical function, let the graph of g be a horizontal shrink by a factor of 1/6, followed by a translation 3 units left of the graph of f of x. F of x is the cube root of x. Write a rule for g. So I'll take this one at a time. G is going to be a horizontal shrink by a factor of 1/6. So that means I am, I'm going to make an h of x, an in-between function is going to be f of 6x. When it's a horizontal shrink or stretch, I take the reciprocal of the factor, and that's what I'm multiplying the x value by. So let's do h of x equals the cube root of 6x, right? The input is now 6x. So, and next, followed by a translation 3 units to the left. So this is a horizontal translation. So this is my h value. So g of x equals h of x minus 3. Is that 3 units to the left? Sorry, that's an h value of -3. This will be plus 3. And so therefore g of x equals the cube root of 6 times x plus 3. G of x equals the cube root of 6x plus 18. Let the graph of g be a horizontal stretch by a factor of 3, followed by a translation 6 units to the right of the graph of f of x equals the cube root of x. Write a rule for g. Horizontal stretch by a factor of 3 means h of x equals f of 1/3 x. Right, we take the reciprocal of 3, which is 1/3, and it's a horizontal stretch shrink. This is a horizontal stretch. So that only affects the x value, so it's 1/3 x. H of x equals the cube root of 1/3 x. And now a translation 6 units to the right, so where h is a positive 6. And so g of x equals h of x minus 6. G of x equals the cube root of 1/3 x minus 6. G of x equals the cube root of 1/3 x minus